All right, question 4. I know there's a lot of reading here. I'll read it out loud. A princess approaches a castle to rescue her beloved prince who has been captured by a dragon. She looks up at the castle and sees her prince waving from the topmost window in the castle and the dragon glaring at her from a lower middle window. The princess stands 250 feet away from the base of the castle. So that's probably important. I'm going to underline that. She remembers from a previous experience in this castle that the top window is 600 feet above the ground. She also knows that the distance from the middle window to the top window is 220 feet. If the princess plans, actually, that's probably important too. If the princess plans to take the dragon out with a bow and arrow, at what angle should she aim the arrow? So that's like our first question. At what angle should she aim the arrow? And then 2, how much larger is the angle of elevation of the princess's view when looking at the top window as compared to the middle window? So I kind of started you off with a sketch on this one. On my sketch, I only drew the top and the middle window. I think we are missing like a lower window. There we go. I can sketch that in. All right. So we were told that the distance from the top to the middle window is 220 feet. We were told that the prince's window, he is 600 feet off the ground. So that's a partial sketch, but there's a lot of information that's missing here. So we also know that the princess is standing 250 feet away. So I'm going to draw her right here and label this 250 feet. Let's see, and I'm just kind of rereading the problem to make sure we didn't miss anything we need in our sketch. So let's see, blah, blah, blah. He's in the top window, 250 feet away. We know 600 feet off the ground, 220 from him to where the dragon is. All right, so I think that's enough to answer these 2 questions. So the first one is, if the princess plans to take the dragon out with a bow and arrow, at what angle should she aim the arrow? So if you think about it, what we really need to know here is she's not trying to hit the prince with the arrow. That could be a devastating end to this fairy tale. She's trying to take out the dragon. So there's a right triangle that exists right here between the princess, the dragon, and the castle. So I'm going to re-sketch that, and I'm going to call this question 1, and we're asked about that angle. So if I just kind of sketch this separate from that picture, because it's a really busy picture, princess is over here, right angle, and we know that this is like where the dragon is. I'm going to write D for dragon. We know that this is 250 feet, and we can figure out how far off the ground the dragon is, because we know the prince is 600 feet from the ground, his window, but the dragon's window is 220 feet less. So we just need to do some subtraction. 600 minus 220 feet, we're left with 380. So that means that this distance from here to the dragon's window must be 380. So 380 feet. My sketch is probably not to scale here. So if you think about it, the angle at which she's going to aim that arrow, this is like an angle of elevation. So I'm going to call it X, and that's essentially what we're being asked, is what's the angle of elevation from the princess to the dragon? All right, so we don't know anything about this hypotenuse, but we know the 2 legs of this triangle. We're trying to find an angle, so we're going to use inverse trig functions. So I could say the tangent of angle X is equal to opposite 380 over adjacent 250. But I need to use the inverse tangent if I'm finding that angle. So it's like I take the inverse tangent of both sides, or I could rewrite this as the inverse tangent of 380 divided by 250 is going to give us X. Okay, so in your calculator, you go to second tan to get inverse tangent, 380 divided by 250, and we get 56.659. So that angle is approximately 56.659 degrees. So that is the angle at which she should aim her arrow. All right, the next question is this. How much larger is the angle of elevation of the princess's view when looking at the top window as compared to the middle window? That's kind of a tough question. We already have part of the information from question 1. So if you think about it, when she looks up at the dragon, she's looking up at him at an angle of about 56.659 degrees. When she looks up at the prince, she's going to be looking higher up. So her angle of elevation is greater. What it's asking us is what's the difference between those two angles? To answer that, we need to know the two angles of elevation, and we found one of them in the first part of that question when we were asked about how far she needs, or at what angle she needs to aim her arrow. So this is going to be the angle of elevation to the dragon, is what we found here. And so what we need now is the angle of elevation to the prince. So angle of elevation to prince. So if we sketch our triangle, it's really similar math we're doing here. I know my triangle is not to scale. Please forgive me, it's not at all to scale. This is 250 feet still, because this is the princess. Now we're looking up at the prince. I'm going to call this Y. We're trying to find that angle of elevation. And we know that the prince is 600 feet off the ground, like we were told that in the problem. So we're still going to use, oh, and you can't see anything I just wrote. I'm sorry. It's hard to do this on a phone. All right, so here's our princess, 250 feet from the castle. The prince is 600 feet off the ground. We're now trying to find this angle of elevation, Y. So it's really the same math as the last problem. We could say that the tangent of Y is opposite over adjacent, so 600 over 250. And then we could use the inverse tangent of 600 over 250 to find the value of Y. So we'll go back to our calculator, do second tan for inverse tangent, 600 divided by 250. And we get 67.380. So Y is approximately 67.380 degrees. All right, so that's the angle that she's looking up at the prince when, that's the angle from the horizontal that she sees the prince. So going back to the second question, it's not asking us what's that angle of elevation, but it's asking us what is the difference. So it says how much larger is the angle of elevation of the princess's view when looking at the top window as compared to the middle window. So it's really asking how much bigger is this angle than this angle. And we can answer that with subtraction. So to answer this question, we would go and do Y minus X, and we would say 67.380 minus 56.659. We're finding the difference of those angles. I'm going to use my calculator so I don't make a math mistake. So minus 56.659. We get approximately 10.721 degrees. 10.721 degrees. So she has to look up about 10.7 degrees more when she's looking at the prince than at the dragon. And that is our final answer for question 2 of question 4. All right, let's go straight into question 5. This one's, I think, easier than the last two problems. So in question 5, Sammy is trying to amaze her little sister with math magic. She tells her sister that she can figure out her height without measuring her. Sammy has her sister stand outside and measures her shadow to be 4 feet long. Sammy also measures the angle of elevation of the sun to be 55 degrees. How tall is Sammy's sister? Again, let's sketch a picture here. So we've got Sammy's sister standing outside. We know her shadow is 4 feet long. And we know that the sun has to be behind her if her shadow is in front of her. So here's the sun. Pretty much could have been an art teacher, I know. Here's the height that we're trying to find. And we're told that the angle of elevation to the sun, or of the sun, is 55 degrees. So remember, an angle of elevation comes up off of the horizontal, if this is our horizontal, this is our 55-degree angle. So it's like you're looking up from the ground to see the sun up at 55 degrees. Okay, so this is a pretty straightforward trig problem. It's not that bad. We don't know anything about the hypotenuse, but we are trying to find the opposite given the adjacent and an angle. So that means that we want to use tangent. So we could say that the tangent of 55 degrees is the opposite, which is Sammy's sister's height, over the adjacent,
Oli,
which
can
is...
you please come to the main office? Oli, can you please come to the main office?
I'm sorry, that's so loud. H over 4 for 4 feet. So the opposite over the adjacent. And just like we've done before, we want to rewrite this so we can plug it in our calculator. So we could multiply both sides by 4 and get 4 times the tangent of 55 degrees. That should give us H. So just go to your calculator and do 4 tan 55. We get 5.713 if we round that. So H is approximately 5.713 feet. Now, I know it's kind of weird to think of, like to talk about feet and talk about 5.7 feet, because when we talk about feet, we're really talking about something that's based off of 12-inch measures, and this is saying 7/10 of an inch. But let's just go ahead and leave this as a decimal to make our life easier. So 5.713 feet is Sammy's sister's height.